Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. When the universe became data, and humanity changed its place in it. At the start of the 20th century, humanity carried a kind of confidence about the universe that today feels almost charmingly bold. Textbooks said it plainly. Professors taught it with certainty. Even the top astronomers of the era more or less agreed on one big idea. The Milky Way was the universe. That glowing band you see stretching across the night sky? Back then, it wasn't just scenery. It was treated as the outer wall of existence. Beyond it, there was no beyond. Like a map that simply ends at the shoreline. And this wasn't speculation. It was consensus. The academic mood was something like, we've basically figured out the cosmos. What's left are minor details. Sound familiar? Every era has that moment where people quietly believe the big questions are already settled. And then someone shows up and ruins that comfort. A young astronomer stepped forward and said something that didn't sound radical, but made the room uneasy. He didn't shout revolution. He didn't publish a philosophical manifesto. He calmly suggested, maybe we live in a much bigger place than we think. In context, that was almost the same as saying, everyone, our cosmic map might be wrong. That young astronomer was It Hubble. The shocking part wasn't the claim, it was what he did next. He went out and measured it. Not by arguing, not by theorizing from a desk. He aimed the best instruments available at the sky and started doing what you might call cosmic bookkeeping. Frame by frame, light by light. As the saying goes, trust, but verify. And when the numbers came in, they refused to behave. Those fuzzy patches of light long labeled as clouds inside our galaxy? They weren't clouds at all. They were entire galaxies. Which means our Milky Way wasn't the universe. It was one neighborhood in a city of neighborhoods. The night sky stopped being decoration and became infrastructure. The universe, in a single intellectual step, transformed from a place into a system. If the story ended there, it would already be one of the greatest scientific shocks in history. But Hubble kept looking, and then things got stranger. Those distant galaxies weren't just sitting there. They were moving away. Not randomly drifting, but collectively retreating. Imagine thinking you're staring at a painted backdrop, only to realize the canvas itself is stretching. This wasn't a correction. It was a worldview reboot. For the first time, humanity grasped something profound. The universe is not a static stage. It's a dynamic process. Astronomy stopped being the science of where things are and became the science of how everything evolves. And the implications went far beyond astrophysics. We weren't at the center. The cosmos wasn't eternal and fixed. Even space itself was participating in change. In plain language, the universe is far bigger than we imagined. And it's still growing. So the real question stopped being, how big is the universe? And became, why is it moving at all? And that's where the modern story of cosmology truly begins. Now rewind the clock to Hubble's early life, and what you see is a perfectly respectable, almost predictable trajectory. Bright student, good family, clear expectations. His father wanted him to become a lawyer. Stable, respected, practical. A textbook success path. And for a while, he followed it. He studied law seriously, completed the coursework. Everything pointed toward a conventional career. The script practically wrote itself. He becomes a successful attorney. But reality loves a plot twist right where things seem most settled. Because while he was mastering legal arguments, his mind kept drifting somewhere else. The night sky. While others planned careers, he wondered what those distant lights really were. How far did space go? What did distance even mean on that scale? This wasn't idle daydreaming. It was a persistent intellectual pull. By day, legal logic. By night, cosmic scale. Two rule systems colliding in one brain, human institutions, and universal structure. Eventually, he made a decision that, at the time, looked like throwing away a secure future. He left law for astronomy. Most people switch jobs and change buildings. He switched universes. That choice wasn't youthful rebellion. It was deliberate obsession. He wasn't interested in solving neatly packaged problems. He wanted to ask a deeper one. Where, exactly, are we? Astronomy then wasn't glamorous. It was closer to a group of people staring into darkness and repeatedly asking, "Did I really see that?" But that uncertainty was precisely what drew him in. A small, tidy world wasn't enough. He wanted bigger questions. Law taught him structure and argument. Astronomy taught him scale. Combined, they created a rare scientific temperament, someone who could question consensus and back it up with evidence. When a person like that points a telescope at the universe, history tends to shift. Looking back, that career pivot didn't just change one life. It changed the size of the question humanity was asking. From, how do I succeed in society? To, where do we exist in the cosmos? And that question was about to collide head-on with the strongest scientific assumptions of the era. The next step wasn't career advancement. It was a map collapse. Many people gaze at the stars for romance. Hubble looked up to audit reality. Precision-level audit. Decimal place precision. Before any universe-shaking discovery came years of disciplined resistance against error. This wasn't a lightning bolt insight story. It was a long campaign against uncertainty. He observed, then observed again. Conditions changed? Repeat. Results looked clean? Be suspicious. He wasn't chasing conclusions. He was chasing reliability. Picture the working conditions: freezing nights, slow mechanical tracking, fragile photographic plates waiting hours for faint light. One mistake and the entire night's work evaporates. For many, that's frustration. For him, it was filtration. Where others saw beauty, he saw variables. Brightness curves, timing cycles, error margins. Romance gave way to numeric order. And in science, as the proverb goes, the devil is in the details. He focused heavily on variable stars. Stars whose brightness pulses in regular cycles. To most observers, interesting phenomena. To Hubble, they were measuring tools. Cosmic yardsticks. Light wasn't just illumination. It was encoded information. Stacks of plates accumulated. Data sets cross-checked. Errors peeled away layer by layer. You can almost feel the tension. The answer is in there, but it only reveals itself to the patient. Then anomalies emerged. Not fireworks. Patterns. Certain light sources behaved in ways the accepted model simply couldn't explain. All procedures were correct. The math checked out. Yet the conclusion whispered, that shouldn't be there. A real scientist's first instinct isn't triumph. It's doubt. Did I mess this up? So he tested harder. New plates, fresh calculations, repeated verification. And the anomaly stayed put, calmly contradicting the cosmic blueprint of the time. This is science at maximum tension, when evidence starts arguing with consensus. Hubble realized he might not be fixing details. He might be touching the boundary definition of the universe itself. And suddenly the suspense wasn't. What did he see? It was, if these numbers hold, our model of the universe has to change. The next step wasn't technical refinement. It was conceptual upheaval. Because he was on the verge of confirming something extraordinary. What he was seeing wasn't part of our galaxy. It was evidence of an entirely separate cosmic structure. And from that moment forward, humanity could never look at the night sky with the same scale again. The universe stopped being a backdrop. It became an unfolding narrative. And we had just learned how to read the first page. Before this chapter in our story, humanity's picture of the universe was comfortable. Comfortable in the way an old map is comfortable. Neat borders, familiar labels, nothing too alarming. The fuzzy smudges in the sky were politely called nebulae, a word that basically meant, don't worry about it. They were assumed to be local scenery, decorative clouds inside our galactic neighborhood. And the dominant belief was beautifully simple. The universe equals the Milky Way. Everything else? Just interior decorating. It sounded reasonable. It felt stable. And as the saying goes, if it ain't broke, don't fix it. But science has a habit of poking at the one assumption everyone is most comfortable with. The most dangerous moment in scientific history is rarely when something looks wrong. It's when everyone agrees it looks right. Behind the scenes, a quiet argument was brewing. Astronomers were circling a deceptively simple question. What exactly are these nebulae? Are they gas clouds inside our galaxy? Or entire star systems far beyond it? This wasn't wordplay. This was a make-or-break question about the size of reality itself. Because if the second option were true, then the Milky Way wasn't the universe. It was just one neighborhood in a cosmic city. Standing right in the middle of that intellectual crossroads was a stubborn observer with a dangerous habit. He trusted measurements more than opinions. Edwin Hubble. He didn't rush to join a camp. He did something far riskier. He decided to measure. His target was one of the sky's most mysterious objects, the Andromeda system. Through the telescope it looked like a gentle swirl of light, harmless, decorative. But if he could nail down its distance, the debate would end instantly. To do that, he hunted for cosmic yardsticks, variable stars. These stars pulse in brightness with clock-like regularity. And here's the trick. Their rhythm reveals their true luminosity. Measure the pulse. Compare the brightness. Calculate the distance. Simple in principle. Brutal in practice. Night after night, glass plates were exposed. Data logged. Numbers checked, rechecked, then checked again because astronomy does not reward wishful thinking. Time passed in silence and red light. And one day, the math lined up. The distance wasn't just large. It was absurd. Not a little beyond the Milky Way. Orders of magnitude beyond. Translated into plain English, that cloud wasn't a cloud. It was another galaxy. You can almost feel the air leave the room. If this result held, and it did, then every faint smudge in the night sky could be an entire stellar metropolis. The Milky Way was no longer the universe. It was a universe among many. This wasn't a minor map update. It was a cognitive earthquake. Humanity's address in the cosmos had just been downgraded from center stage to one island in an archipelago. And the most beautiful part? This revolution wasn't born from bold speculation. It was built from patient measurement. Numbers beat intuition. Evidence rewrote belief. But science never stops at the first shock. Once astronomers accepted that galaxies existed beyond our own, a new, more unsettling question emerged. Were those galaxies just sitting there? Or was something bigger happening? Because around the early 20th century, astronomers noticed something strange. Light from distant galaxies wasn't behaving neutrally. Its spectrum was shifted toward red. This wasn't aesthetic. It was physics talking. Like a passing train dropping pitch as it moves away, light stretches when its source is receding. That stretch is called redshift. At first, it was treated as local motion. Maybe a few galaxies were drifting. But as the data piled up, a pattern emerged. The kind scientists dream about and fear at the same time. Hubble plotted two columns: distance, velocity. Then he did one of the most elegant acts in scientific history. He drew a line, and the points didn't scatter randomly. They lined up. The farther a galaxy was, the faster it was moving away. Not some galaxies, almost all of them. This wasn't cosmic coincidence. It was structure. The universe wasn't static. It was expanding. And here's the mind bender. Galaxies weren't flying through space like sparks. Space itself was stretching. Imagine dots drawn on a rubber sheet. Pull the sheet, and every dot sees every other dot moving away. No center. No VIP seating. Just scale changing. That's the universe. In one stroke, thousands of years of intuition were overturned. From ancient philosophy to classical mechanics, the default assumption had always been, space is the stage. Things happen on it. Now science calmly announced, the stage is moving. The universe wasn't a frozen backdrop. It was a process. And once you accept expansion, a deeper implication follows naturally. Run the film backward. The universe gets smaller, denser, hotter. Keep going, and you approach an extreme beginning. Not philosophical speculation, a conclusion forced by observation. For the first time, humanity had to confront a radical idea. The universe has a history. It evolves. It has a past. Maybe even a beginning. Astronomy had quietly transformed into cosmology. Not just asking what's out there, but how reality itself unfolds. From a tiny spectral shift to the timeline of the cosmos. A chain of logic so clean it almost feels inevitable. Data pattern theory, cosmic history. And the shock wasn't emotional. It was clarity. The universe wasn't a timeless container. It was an unfolding story, and we just happened to live on one of its pages. Which leads to the next irresistible question. If the universe is evolving, what else is hiding in plain sight? For most of human history, we treated the universe like a finished building, solid, permanent, no renovations planned. The default assumption was simple: the cosmos had always been here, unchanged. No growth, no shrinkage, just an eternal backdrop where things happened. Comforting, stable, case closed. Then along came a telescope, a stack of photographic plates, and a stubborn observer who accidentally kicked the door open. When Edwin Hubble showed that galaxies are rushing apart, he didn't just add a footnote to astronomy. He flipped the logic of the universe on its head. Because if the universe is expanding now, rewind the tape. Earlier, it must have been smaller. Go back further. Smaller still. Keep rolling that cosmic film backward and you're driven toward a startling implication. The universe may have had a beginning. That chain of reasoning didn't come from armchair philosophy. It wasn't poets staring at the sky. It came from distance measurements, spectral lines, and data so dry it could put coffee to sleep. Yet those measurements lit the fuse of modern cosmology. Scientists stopped asking only, what's out there? They started asking the bigger questions. Where did the universe come from? How does it change? Where is it headed? And the beautiful irony is that this grand narrative grew out of something almost mundane: careful bookkeeping of light. Hubble's deeper contribution wasn't just discovering more galaxies. He helped invent a language for cosmic scale. He turned the sky from a mysterious ceiling into something you could measure, classify, and reason about. Galaxies stopped being fuzzy decorations. They became systems, with structure, patterns, and rules. It was like upgrading from a sketchy travel map to a precision satellite chart. The conversation shifted from, what's over there? To, how does this whole thing work? And that shift mattered far beyond astronomy. It rewrote humanity's sense of place. We were no longer standing at the center of a cosmic stage. We were participants inside a vast structure. Tiny, yes, but embedded in a grand unfolding process. Surprisingly, that realization didn't shrink our significance. It expanded it. Because the ability to understand the universe is itself extraordinary. Here we are, standing on a planet orbiting an ordinary star, yet capable of reconstructing billions of years of cosmic history. That's not just clever. That's borderline miraculous. Hubble sits right at a critical junction in that chain of understanding. His work pulled the universe out of myth and into measurement. It transformed the cosmos from a static painting into a dynamic story. For the first time, humanity grasped a radical idea. The universe isn't scenery. It's an event in progress. And we are inside it. So when you look up at the night sky, you're not just seeing pretty lights. You're seeing distance, time, structure, and evolution braided together. That quiet darkness is full of motion and memory. And all of that traces back to someone who insisted on taking light seriously. Someone willing to keep asking, how big is this thing, really? Sometimes world-changing revolutions don't arrive with trumpets. They arrive with a ruler, patience, and a question that refuses to go away. And the answer, as it turned out, was bigger than anyone bargained for. What Hubble did with a telescope looks surprisingly modern today. He treated the sky like a data interface, not decoration, information. Wise astronomers don't just look at stars. They run diagnostics on the universe. Deep field imaging, spectral analysis, timing measurements, gravitational mapping. In plain English, they're giving the cosmos a full-body checkup. And the core logic behind all of it echoes Hubble's approach. Measure first, interpret second. As astronomy pushed into deep space, scientists ran headfirst into a practical problem: Earth's atmosphere. Great for breathing, terrible for sharp images. It's like trying to watch a movie through rippling water. So scientists made a bold call. If the air is in the way, move the telescope. That decision led to the era of the Hubble Space Telescope. Not just an equipment upgrade, but a leap in perspective. For the first time, humanity could observe the deep universe without atmospheric distortion. The result? The cosmos switched to high definition. Nebulae revealed themselves as stellar nurseries. Galaxies appeared as spinning, colliding, evolving ecosystems. We even captured light from the universe's early epochs. Baby pictures of reality itself. If Hubble once measured the universe with a ruler, modern astronomy films it in ultra-high resolution. And the real shock isn't that the images got prettier. It's that precision now shapes theory. We can detect a star's tiny wobble and infer invisible planets. Measure subtle spectral shifts to refine the expansion rate. Probe extreme gravity where time itself behaves strangely. This isn't sightseeing, it's auditing the universe. Every dataset asks the same blunt question: does reality agree with our theory? Modern deep space observation is essentially Hubble's methodology turned up to 11. Farther reach, finer precision, braver questions. Every cosmic image you've ever seen, star birth, galactic collisions, dark matter maps, isn't just eye candy. It's measurement made visible. Physics rendered as scenery. And here's the twist. The clearer the picture gets, the more mysteries appear. What is dark energy? How will cosmic expansion end? Are there deeper layers of structure we haven't spotted? Better tools don't close the case, they upgrade the questions. That's the magic of the observational revolution. It doesn't just show us more, it reminds us how much remains unknown. In other words, the more you know, the more you realize what you don't know. And that's not a bug, it's a feature. If modern astronomy is an ever-updating documentary about the universe, Hubble pressed the first record button, and the episode is still airing. When humanity discovered that the Milky Way wasn't the whole universe, the real shock wasn't academic, it was existential. For centuries, we had a habit of casting ourselves in the lead role. Earth at the center, then the Sun, then our galaxy. The universe felt like a showroom built with us in mind. Hubble's measurements calmly dismantled that illusion. The Milky Way turned out to be one galaxy among billions. Like thinking you live downtown, only to discover you're standing in one corner of a continent. Oddly enough, this didn't diminish humanity. It matured us. It replaced cosmic ego with curiosity. Not we are nothing, but we have so much left to learn. That mindset, skepticism paired with wonder, is one of science's greatest strengths. Not doubting for sport, but refusing to settle too quickly. Whenever a theory looks perfect, a good scientist asks, how could this be wrong? Hubble's era was a triumph of that attitude. While many were comfortable with the old cosmic picture, he let the data speak first. Reality over preference. It sounds obvious now. It wasn't then. And the ripple effects extend far beyond astronomy. Exploration stopped being about reaching an edge and declaring victory. Every boundary became an invitation. Why is expansion accelerating? What is dark energy? Does spacetime hide deeper layers? We don't have all the answers. And that's the reassuring part. An unfinished story means discovery is still on the table. As the universe grows larger in our understanding, humility grows with it. Not because we're insignificant, but because we recognize knowledge itself as a journey. The farther we travel, the farther the horizon moves. So when we look up at the Milky Way today, we're not just stargazing. We're participating in a century-long upgrade of perspective. Every photon is a historical record. Every observation asks again, who are we in all this? We once thought the galaxy was everything. Turns out, it was just the opening chapter. The universe is expanding, and so is our understanding. The real story isn't that the cosmos got bigger. It's that our perspective finally caught up. Hubble didn't enlarge the universe. He expanded human vision. And in the quiet dark above us, The story keeps unfolding. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.